Hello everyone, today I'm going to touch on our first lesson, which is on Design Sketching 101, more specifically on understanding the different projection types. Okay, for our first lesson, I would like to cover these four methods of projection that will be commonly used for our lessons currently as well as for next year's program. Okay, the first one that we're going to cover will be on oblique projection. The second one is on isometric projection. The third one, perspective, and lastly, orthographic projection. For the purpose of our design studies modules, we will be paying particular attention to number 2, the isometric projection, as well as number 3, perspective projection. But having an understanding of oblique projection as well as orthographic projections will also enable us to understand the different projection types better. Moving along, okay, what I would like to highlight firstly is on oblique projection. For this particular view, what we will notice is the angular inclination that this side will make with respect to the horizontal. In this particular instance, for an oblique projection of a simple regular cube, what we can see that this particular edge over here has an angle of 45 degrees with respect to the horizontal. And this is peculiar to all oblique projection. This projection is particularly a projection that most students or rather beginning students in design sketching would probably resort to, okay, when they first start out on coming out or sketching out a regular cube. So what we can see over here is the two sides, this axis, these lines over here and these lines over here, still maintaining perpendicularity as well as parallelism to the horizontal axis, whereas the third axis maintains a 45-degree angle. Now, one main shortcoming of this particular projection is the fact that these lines over here, these two and these two and this one, okay, will be seen to be shortened in length in order to achieve a more realistic view. Now, this idea is called, or rather this concept is known as foreshortening and will be covered in subsequent lessons. So, in fact, with this shortened length of sides, okay, it will definitely create some form of distortion, okay, in terms of people looking, even though this object is a regular cube, but when one is captured in an oblique projection, one will notice that this is actually not the same length as this. Moving forward, the second projection that I would like to cover today is on isometric projection. Now, for this projection, one will notice a key difference here in terms of not only the angles, but the number of sides or the number of planes that will be inclined to the horizontal plane. Firstly, the angle of 30 degrees, okay, or estimated to be 30 degrees in design sketching, will be an angle that all of you will have to take note of. The second one is the non-perpendicular, or rather the non-parallel nature of this particular side over here when you compare it with the oblique projection. So this edge and this edge over here will be at an angle of 30 degrees, whereas the vertical edges, these three over here, will maintain perpendicularity with respect to the horizontal plane. Now, of course, there is also one disadvantage of this projection, and the disadvantage is the distorted view that one will notice, although this is somewhat slightly better compared to an oblique projection. Now, it is highly advisable that students starting out in design sketching adopt methods that will enable them to fluently reproduce isometric cubes, okay, rather than oblique cubes, because coming up with isometric cubes will enable them to move ahead, or rather to do better or to reproduce things better in other shapes in subsequent levels of difficulty of design sketching. Next, I would like to cover perspective projection. Now, perspective projection for design studies, we will be basically covering two different types of perspective. Firstly is a one-point perspective. Now, this is usually denoted by a single converging point, also known as vanishing point over here. Now, in some instances, there will be sketches in which a horizontal line will also be added, and this is known as a horizon or the horizontal line. So, the VP or the vanishing point will act as a point of convergence of all the lines, as you can see over here. And do take note that vertical, or rather perpendicular lines with respect to the horizon, as well as lines that are parallel to the horizon, will maintain their level of orientation in a one-point perspective. You can see in this particular diagram over here, there are some naming conventions for all these lines, and how some of these lines will remain horizontal, like what I mentioned earlier, as well as vertical with respect to the perpendicular line or the horizon. This is somewhat different when you take a look at 2 points perspective. Now, in 2 points perspective, instead of one, we have two vanishing points. In some literature, we will refer this as VPL, or vanishing point on the left, and VPR, or vanishing point on the right. Now, one key difference is that for two vanishing point perspective, only the vertical axis or the vertical lines or the perpendicular lines to the horizon will remain in its original orientation, whereas the other lines will converge to either the VPL or the VPR. Depending on what is the final intent of the view that you want to achieve, okay, having these lines, okay, will achieve three different effects. One, a bird's eye view. Second, a street level view. And the third, a worm's eye view. Understanding and knowing how these lines come about, okay, will enable you to depict three different types of view of the same object. Here, I would like to show you some examples of 2-point perspective. The example over here, what you can see, okay, the two vanishing points are located at quite a significant distance, with the focal object over here being a house, okay, being placed in the center. Over here, what you can see is a street view where the buildings on the left, the lines making up buildings on the left converges to a VPL over here, and buildings on the right hand side, okay, converging to a VPR over here. Now, similarly, the third diagram over here shows us a house, okay, which is slightly higher compared to this. Okay. Now, what you can probably see, okay, is that this house looks more centered compared to this house. This house seems to be placed a little bit lower, and if this is the intent of the 2-point perspective, or the intent of how you want to depict the house, then of course it is desirable. Okay, so this is probably of someone looking down at a house, okay, from a top-down perspective. So, or perhaps maybe you might want to show some features on the rooftop, which might not be able to be seen clearly if you were to draw it in this perspective. Lastly, I would like to touch a little bit on orthographic projection. Now, in orthographic projection, okay, namely we will have consist of two types of orthographic projection. Firstly, you have your first angle, and the second one will be third angle. Now, there is no such thing as a second angle projection, so don't be mistaken that there is something over here that is not being featured. Now, in the first angle projection, what you will probably see, okay, is okay, this is a good example of a first angle projection. Okay, so imagine if this is a product that's going to be featured, and if you are standing over here, what you can see from this side will be showcased on this side. Okay, so what you will notice that the view that you probably see from this side of the object would be highlighted, showcased, or reflected on the opposite side of the object. Similarly, if you are actually looking the object from a top-down perspective, okay, the view from the top will be shown at the bottom over here, which is shown over here. Okay, so to summarize, what we can actually see is that a top-down, a first angle projection, okay, will show the object or the view of the object in the opposite plane. This is similar to the other examples that you can see over this side as well as over here. Moving forward, this is another example. This is an example of a third angle projection in which the point of view will be on the same side, okay, same side as the viewing position. So if you are standing on, for example, this side, what you can see over here will be reflected on the same side that you are standing. So understanding or knowing the difference between the first angle and the third angle will enable you to differentiate between both projection types. It is good to know that usually the first angle projection is used in most in Singapore, for example, as well as in some European countries that adopts the Commonwealth system of units or Commonwealth systems of design or angular projection. The third angle is usually used in for example, in US companies or in the US. So that will be the main difference between the first angle and the third angle. To explain the difference between the first angle and the third angle orthographic projection, let's take a look at a short video.
Hello and welcome to Clan McCad. Okay, so today we're going to have a look at first angle and third angle projection in engineering drawing. We're going to look at first angle first, and what I want you to think of is having the actual object you're going to draw on top of the paper itself. All you're going to do is imagine yourself rolling the object in the direction of whatever view you're looking to create. And what you see from the top down is what you draw. Okay, so for third angle, I like to think of it as if you're unfolding a cardboard box into that traditional flat pack pattern, looking at the front view itself as if that's all you've got to start with. What would be on the right hand side of that object would come out to the right, and what would be at the top will come out above it. Now, viewing these side by side, you can understand why some would compare them as direct opposites to one another. I like to think of them, as I've shown you, in two different ways entirely, and I hope that helps you remember it. In my next video, I'm going to use the exact same setting to lay out a small mechanical component in separate views. It has some asymmetric features and holes and things that will help it really get across a realistic example of how to do this. Thanks for watching, and I'll see you next time.
In this second video, what we're going to see is a difference in first angle and third angle orthographic projection using an actual 3D model.
Hello and welcome to Clan McCad. So today we're going to have another look at third angle and first angle projection using this little guy here. Now this is an X-ray view of the object. Everything in light grey is the solid body, and everything in dark grey are holes travelling through the object perpendicular to our current view. Now, on the left hand side, you can see a feature that ends with a dome and a hole that travels not all the way to the edge, so that will be concealed from any external viewing. On the right hand side, however, we have a cylinder where a hole does travel all the way out to the edge, which we'll be able to see right through from the external side. At the top there, we have another hole travelling through, which just allows asymmetry in that direction as well. One side will have a hole, the other will not. Okay, so here's a quick look in 3D, just to back up what I've just told you. So once again, let's look at first angle first. Now we're going to use the same front view in each example. The cylinder is going to lie on the right, the dome at the left, and the hole at the top, as far as unique features go. What we've got to remember is to use that 90-degree roll in the direction of whichever view we're trying to create, and whatever you see looking straight down from the top is what you're going to draw. The result of this, as you can see, is that each respective feature on the front view lies on the opposite side on each projected view. So the cylinder on the right, the drawing of that facing you lies on the left, the hole at the top lies on the bottom. Okay, so moving on to third angle, again we're going to use that exact same front view, and using that cardboard box thought pattern I explained in the last video, you can quite easily see that what we're going to do is we're going to pull out the nearest side to the view we want to create by 90 degrees until it faces us, and again just from the top down, looking down, what do we see? That's what we draw. Now what you'll notice from this method is that the features on the front view actually lie in the projected view that's on the same side as it is on the front view. So the cylinder on the right there is in the right hand projected view, and the hole at the top is in the top projected view. Okay, so once again, I'll end this on a comparison so that you can kind of decide for yourself how you would maybe like to remember it and see the difference between the two. So that's probably us for third angle and first angle for at least a while. Let me know what you thought of the videos, and if you have any suggestions as to what direction you'd like me to take on any videos CAD related or drafting in general, let me know. I've got a few ideas in the pipeline. Next thing's probably going to be 3D modelling methodologies. It's not really something that's heavily discussed, and I really want to dig into that properly, so that'll probably be the next thing coming your way. Thanks as always for watching, and I'll see you next time.
Okay, so just to summarize, okay, these will be the key differences between the first angle and the third angle projections. Okay, let's have a closer look. Okay, taking note of the different symbols over here, one can clearly see what are some of these key differences. For the first angle projection, whatever that one sees over from this side, okay, will be seen on the opposite side, which is what you notice over here. Alternatively, for a third angle projection, whatever that one sees from this side, okay, will be reflected on the same side as the viewer. Okay, so if one sees this from the left hand side, so the view that he or she sees will be depicted on the left hand side. So this is one key difference between the first angle projection and a third angle projection. So to summarize, what we have done so far for this particular lesson is to understand the 4 projection types in design sketches and drawings, namely the oblique, the isometric, the perspective, and lastly the orthographic projection. Okay, what I have covered also for this lesson is the different projection types and its suitability for different contexts. And lastly, I've also covered some basic or some ideas about the advantages as well as the disadvantages of each of these projection. I hope you have a better view or you have a better idea of the 4 different types of projection which we are going to learn or which we're going to cover in subsequent lessons. Have a good day.